Histogram-based outlier score, HBOS. HBOS will construct a univariant histogram for each feature. For each feature, an individual histogram will be computed. The height of each single bin represents density estimation. There are two types of features. The first type is categorical features. We will count the values of each category and then calculate the relative frequency. For numeric features, we can use static bin-wide histogram, or we can use dynamic bin-wide histograms. Depends on how we define the bin-wide. Finally, the HBOS of every instance is calculated using the corresponding height of the bins where the instance is located. We can see from the equation that basically the score is a multiplication of the inverse of the estimated densities. To summarize the characteristic of HBOS, HBOS is faster than multivariate approaches, and the computation cost is low. The shortcoming is that it will be less precise. Meanwhile, this algorithm assumes that all features are independent. An interesting variant of HBOS is subspace HBOS. This variant is faster than both conventional and high-dimensional algorithms, and we can use this algorithm to discover outliers in a real-time dataset. The next algorithm we will choose is local outlier factor, LOF. The basic idea is that LOF algorithm will calculate the degree of being an outlier for each object. It uses a distance-based method to calculate how isolated the object is compared with its neighbors. It creates a measurement of the density in the neighborhood of each observation. We also call it local reachability density. And then we will calculate the local outlier factor based on this measurement of density. Compared with other sophisticated algorithms, we can say that this is still a fast algorithm and is also efficient for discovering local outliers. If we try to have a review on existing literature, we can find many variants of LF. The first one is using the cosine similarity instead of distance for sparse dataset. The second and the third one is trying to modify the equation. The second one for the purpose of simplicity, and the third one is for the identifying the small outlier groups. The fourth one tries to use a grade-based method to deal with the cluster of different densities. The fifth one provides the probability as a score. Therefore, we can use those probabilities to compare different results. The final one can identify the number of neighbors automatically. We can summarize that these variants all try to improve or modify the LF for specific purpose.